Hi, my name is OliviaMostow. I am a rising third year UVA, and I am double majoring in astrophysics and statistics. And for this summer, I participated in the University of Florida's Astronomy REU program, and I worked with Dr. Paul Torrey on galaxy formation simulations, and specifically, we worked on solving the core cusp problem in low-mass galaxies to answer the question of if a single burst is enough. And to elaborate a bit on what all of that means, the core cusp problem is one of the small-scale tensions between our current model of cosmology and what we actually observe about the universe. So essentially, what we expect to see is that the density of dark matter will just continue to increase as you get closer to the center of a galaxy. But what we actually observe is that it flattens out at some point. And so this tells us one of two things. Either we're missing something from how we're thinking about dark matter, or we're missing something from how we're thinking about galaxy formation. And by that, meaning we need to incorporate some kind of feedback effects. And so my project focuses on one particular feedback effect called bursty feedback, which has to do with the effect that bursts of star formation have on the density profile. And so just to give a quick overview of how that could solve the core cusp problem, if you imagine a single particle of dark matter orbiting a dense cloud of gas, and then because you had all of these stars form around the same time, you have all of these supernovae that happen around the same time. So you have a ton of energy, a lot of mass gets expelled in a very short period of time. And so this causes the particle to migrate outward, essentially. And then the gas can reaccrete, but because the particle's further away, it doesn't feel as strong of a gravitational force. And so this can just keep happening and cause a lot of the inner particles to migrate outward slightly. And this has the effect of flattening a steep cusp profile into a core. And the reason that we're interested in if this can happen in a single burst of star formation is because of these recent observations of Milky Way satellites that show that all of the stars formed in a relatively short period of time. So without going into too much detail, this plot on the left shows how tightly all of these stars, all of these points, are constrained to this red line, which represents an age of 13.7 gigayears. In other words, very long time ago. So these stars formed all around the same time and all a very long time ago, and this provides a really interesting challenge to bursty feedback as the solution to the core cusp problem. And so my project is to use these simulations to not only look at if it's possible to form a core in a single burst, but also why or why not. And so I just want to quickly thank all of the people who have made this summer possible and such an amazing experience for me. So firstly, Ashley and Mike, who organize all of the surf activities and the program as a whole, who do so much to make the experience so great for all of the students. And then Deshika and Paul, who organize the astronomy program and have provided continued support and guidance to all of the astronomy students. And of course, a second thank you to Paul for guiding me through my project and teaching me everything that I know. And finally, to all of my fellow students who have made this such an unforgettable summer. It wouldn't have been the same with any other group of people. I've made a lot of great friends, and it's been an amazing experience.